Today we're looking at note 7.3, natural base exponential function. So the natural base exponential function is y equals e to the x. So e represents a number. It's something you might have already talked about in your science class. E represents a number that is approximately 2.72. So it's kind of like pi. You know, pi is 3.14, so e is 2.72 approximately. So to get the graph of y equals e to the x, let's talk about plugging in some x values. So if I plug in -3 for x, e to the -3 here, e to the -2, e to the -1, e to the 0, anything to the 0 power is 1, e to the first, e to the second, and e to the third. That's taking all these numbers, plugging them in for x. This is what you would type in the calculator. Okay, obviously e to the first is going to be about 2.72. All right, all the other ones you need to plug in the calculator. So you have the choice. You can go to the home screen of the calculator and you can type in E. E is the button that you'll have to hit second, and then this ln button. That gives me E, and it already has the exponent ready to go. So I would type in -3. So that's about, if I want you to round to the hundredths place, 0.05. Okay, so a faster way, obviously, than doing this one by one would be to go to the y equals, plug in e to the x, and look at the table. Okay, so for -3, it's 0.05. For -2, it's 0.14 if you round. And then for -1, it's 0.37. And then we already knew these two. And then 2 is going to be 7.39. And then 3 is 20.09. Okay, so obviously with this, we're going to have to do our best. So -3 is about 0.05, not 0.5, so that's very small. -2 is 0.14, still very small. -1, 0.37, less than a half, so still very small. And then 0, 1, and then 1, 2.72, so almost 3. And then 2, 1, 2, 3, 4, 5, 6, 7.39, so almost 7.5. And then obviously 320 goes off the graph. So just like all my other exponential functions, this exponential function has an asymptote, you guessed it, here on the x-axis, because there is no such number that I can plug in here for x to produce 0 or less. So I have an asymptote on the x-axis. I'm going to highlight it because it's kind of hard to see. Okay, so let's talk. As with my other exponential functions, parent functions, my domain is x such that x is an element of reals, goes all the way left, all the way right forever. In other words, -infinity, positive infinity. My range, y such that y is greater than 0, or 0, infinity. My asymptote for the parent function is y equals 0. And also, same as all the others, for my parent function, the y-intercept is 0, 1. Okay, my max and min over the interval -1 to +1 is my max. Highest point is this one here in that pink region, and that's at where x is 1, so that's at y equals 2.72. And my min is here when x equals -1, so my min is at y equals, 0.37. So really, I should be doing approximately, because it's not quite exactly, it's a rounding. Okay, so there's my max and min. Remember, if the graph shifts, to find the max and min, instead you're going to have to plug these values in where you see X and determine which one's higher, which one's lower, and that'll tell you which one's your max, which one's your min. Okay, so kind of off to the side here, what I want you to practice is some transformations. So if I give you y equals 1/4 e to the x plus 2 power and then plus 3, how does that graph transform? Well, the 1/4 is a vertical compress or shrink by 1/4. The plus 2 shifts the graph left 2, and the plus 3 shifts the graph up 3. Okay, another example would be y equals -3 e to the x minus 2 plus 1. Well, remember the negative makes the graph reflect over x, and the 3 makes the graph vertically stretch by 3. And the minus 2 shifts the graph right 2, and the plus 1 shifts the graph up 1. Okay, so it is the same as with any other parent function. Okay, so now let's talk about when you will use e. So e is a pretty common letter/number, I guess you would say, that's used in a lot of banking, like continuously compounded interest. So there's this formula, A of t equals P times e to the RT. We call it PERT. Okay, this formula represents continuously compounded interest, where A of t is the amount in the account at, obviously, time t, where P represents the principal, almost the starting amount, and R is the interest rate, annual, okay, and T is time in years. For example, okay, if you invest $500 in an account earning 4% interest compounded continuously, how much money will you have in 6 years? So I invest $500. That's my principal. That's what I start with. Okay, so P equals 500. E stays E. My 4%, that's my interest rate. Okay, but remember to make the percent a rate, I move the decimal over twice, so it's going to be 0.04. Okay, my T is time in years. Well, I've got 6 years. Okay, so plugging into that formula, A of 6, because we're talking about 6 years, equals P, 500, principal, E raised to the R, 0.04, times T. So times, put a little dot there, 6. So you can plug this in your calculator pretty easily. If you go to the home screen, all right, remember, 500, to get the E, it's the, let me see if I can fit this on the screen, second ln gets the E. Okay, it's already in the exponent now, so 0.04 times 6, hit enter, and voila. So A of 6, the amount in the account after 6 years, that's what that means, amount in the account at 6 years equals, and again, I should really do approximately on this one, approximately, let me let you see it, $635, and if I round, oh, this is getting sloppy, sorry, $635 and 62 cents, $635 and 62 cents.